Last year our chassis was made primarily out of aluminum, and as you know, as light and common as that material is, we knew that we needed to be even lighter. We got a significant donation from both Janicki Industries and Boeing and the Boeing Company for already laid up and cured carbon fiber, and Boeing gave us dry carbon fiber, and so we're able to lay up and cut out our own products or our own pieces. The entire frame now is about 90% carbon fiber, and that reduces our density of material by about a third. So we shaved off about 25 pounds from last year. Through structural analysis and with all the strength properties that we've gotten from the companies that donated to us, we've found that we still have a very solid factor of safety, and we know that strength is not going to be a problem for our chassis.
My name is Robert Blosser. I'm the team lead for the chassis. My personal project over the past couple months has been to revise the wheel. The wheel of the Rover originally was much smaller. We were running into issues with ground clearance, and because of that we needed to raise the chassis up, but we also had this innovative idea to house the motors inside of the wheel. This rim that I'm holding is this new design, and it has a cavity in the back of it for the motor to be housed inside of it. The tire size has also increased, and so we are gaining ground clearance from just having a larger tire, but also being able to sink that motor inside. We won't knock the back of the motor on obstacles nearly as much as we were previously.
We're implementing 4 sensors into our soil analysis system: the pH sensor, a temperature sensor, a humidity sensor, and a vibrational sensor. The reason why we went with the pH sensor is because it will help identify if plants will be able to absorb nutrients in the soil, and that's a key feature if we're looking for probability of life on extraterrestrial planets such as Mars. And a vibrational sensor is very key in order to detect if there's any seismic activity going on the planet, and to really understand the insides of the planet, such as the mantle, or if there are any tectonic plates that are present within the planet.
So I'm Andrew Crane, and I'm the design lead on the claw for the Mars rover. And the interface is designed to be astronaut friendly, so that an astronaut using large gloves can go in and change out components as necessary in the field with ease. This year's claw design features 4 fingers as opposed to our 2-finger design last year, and primarily that's because we had trouble both with servos on the 2-finger claw, as well as troubles gripping valves, turning things, kind of delicate allocation of where our hand is actually going.
My name is Mark Meister. I'm working on the data and communication systems on the rover. We've currently tested the control systems using the 2.4 gigahertz transmitter, and we are in the process of upgrading to a 433 megahertz transmitter to extend our range. So we've tested our video transmission equipment up to about 400 meters right now. We're going to be adding 3 more cameras to the system, with one of the transmitters having selectable cameras. We will also be upgrading our antennas used for the video transmission, and we will be adding a second transmitter with operating at 900 megahertz instead of 1.2 gigahertz.
She's a runner, rebel and a stunner, on the